Morning all. When I say all, there's probably not many, but that's okay. Decided to chuck in a cheeky stream at 10:30 today because tonight I've got parenting duties. So I'm not expecting a massive turnout, particularly from the Australian contingent, who's probably sitting at their desks all hacking away at their day-to-day roles. So, rip them. Anyway, so to keep this, I'm aiming to keep this one to about an hour and a half, given that it is in the middle of the workday. And I think in order to sort of make that time the most useful, we'll probably just stick to doing PicoCTF stuff. So we're going to kick that off from where we left off. So hopefully you'll be able to see this. There we go. And where we left off last night, oh, by the way, tea. Make sure you got your tea. Hey, Jiggins! Thanks for coming in, bro. Sysop. Yeah, work. Tell me about it. Hey, nice to have you guys on board. Grab your teas if you haven't already. I'm back on the Gyokuro today, which is brewed to perfection. Hacking without tea is very uncivilized. Okay, so when we left off, I think we were about to do another reverse me, weren't we? Is that what it was? Yeah, another reverse me. And we ran out of time to finish that, so let's look at that first thing. We didn't get the source for this. And so, when we run it, can you figure out my trick? We're probably going to have to disassemble this. So maybe let's have a quick look at GDB. And have a look at main. What's going on here? Call do magic. So clearly we read in some data and then we do magic and then we spit something else out. So let's have a look at what do magic does. Ooh. Looks pretty gross, doesn't it? Mem set. It looks like there's some kind of shenanigans going on here that we're just going to have to step through. Now I know there are a bunch of tools that can automate the process of handling all this stuff, but I think we should go and do it ourselves. So let's break it, do magic, and we'll run it. Read input. Let's step past this read input function, which is clearly probably going to ask us for some text. So let's go A, B, C, D, E, F, G, H, and let's see where this takes us. So EAX points to the area of memory that we read that in. Clearly it's just sitting in what looks to be global sort of static memory. Not static memory, the what's it called? The data section. So let's have a gander at what happens next. So we call string length strlen of what we've just been given, and that would obviously return the new line as well by the looks of it. So this should be 9 characters, which we can see there. And then what are we doing? We are calling malloc with 10. Okay, so we're allocating enough space for whatever that was given plus 1, which I assume would be for the null byte. And then what are we doing? Are we checking to make sure that that malloc succeeded? Yeah, that's exactly what we're doing. So that means then that this is sitting on the heap. Is that right? 45F0. 4B5F0, my bad. So yeah, there it is. It is on the heap. Okay, so make sure that that's not null. And if it's not null, then we carry on doing this other stuff. So it bombs out if the memory allocation failed. So EAX is just again keeping track of how many characters there are. So the 9 that we entered plus 10 adds 1. Where are we adjusting the stack slightly? Pushing that value, pushing 0. Okay, so we're clearing, basically calling memset. And passing in 0 and the pointer that we've just allocated on the heap. So it's just clearing that and setting it to null. Hey Bitwise, how you going, buddy? Ooh, you got some Russian caravan on the go. That's a win. Thanks for coming in, guys. Now what are we doing? We are what looks to be setting something to 0, setting something else to 0, and then this is probably starting a loop. So EAX is 0. We're comparing EAX to whatever EBP minus 10 is, which is what? X WX EBP minus 10. That should give us, oh, there you go. Alright, so we're going to loop through however many times based on the string that was passed in. That's what that looks like. If it's less than, then we keep looping. So from here we go and pull out. What are we doing here? We've got 0 as our starting value, and we're adding this, what looks to be, it's either a memory address or a hard-coded value. Let's have a look at 16BX. Maybe this is like a magic XOR key or something similar. Either that, or, you know, we're expecting to see like PicoCTF or something appear in here. Okay, so then we read out, here we go. We're reading this thing byte by byte by the looks of it. We're taking the value out and storing in ECX, so we can see the first character is 29, which is what we saw just here. Secret buffer. That's a good sign, isn't it? And then what are we putting in EDX? 0. Move EAX. Okay, so here we go. We are adding EAX to EDX, so that's again offsetting into the string that we gave it. And then we move the first character into EAX, and then we XOR that with the byte that we were given. And we store that in the local variable. EDX is still 0. You have now entered the duck web and you're in for a honking good time. Can you figure out my trick? So this is like clearly, for some reason, this is the flow of this feels a little bit different compared to when we first start the app, right? We don't get the input prompt that we had before. But anyway, let's just keep going. So that's spitting that out to screen. And what are we doing here? Comparing, add, incrementing our local variable, and again doing a check. So then we're going to grab the next one, and we're XORing that as well. We're basically going to keep doing this all the way through. My guess then would be that this secret buffer, so if we go XS, what was it called again? Secret buffer. Did you see it? It was yellow text somewhere, wasn't it? It was earlier than this. Where did I do my memory read? Come on, don't make me scroll too far. There it is. What do I need? Oops. I think it's that. Info var secret buffer. So that's where it sits. So I'm assuming that if that's supposed to be like the PicoCTF key, hey Peleus, thanks for coming in, mate. Then maybe we just need to, maybe it's got like a rotating XOR or something similar. So look again where we're up to. It's actually XORing Maybe I'm missing something here. This has to do magic. So it's calling put S on whatever this is right at the end and jumps to 713, which is right at the end. I wonder if there's a condition here. Okay. So I assume that what's going to happen here is that whatever's in here gets... you are a winner. So there is a comparison that goes on, right? Add EDX, EDX. Pull out the next character, see if you get to the end. Add one. Compare that to here. Sub ESP push blah call. Okay, so is this expecting then that there be 19 hex 19 characters? Because it looks like it's comparing however many characters it's done with 19 and then jumps. Maybe I'm getting that wrong. Let's just quickly go through here again. Pull out the next byte. Compare that to EVP. AL is a space. I don't think this is running how I expected it to. Maybe it is. Any ideas? It does look like gibberish. Hey, Movix, how you going? Morning, Rivets to Rivets. Thanks for joining in. I'm just trying to understand what I'm seeing. What I might do is just load this up in like Binger or something so that we can see the flow. I don't do very good at reading linear graphs because I'm crap. And that's okay. So what was it? It was read input, wasn't it? So let's restart that. Okay, so read input is just doing a straight get line. Okay. Push EAX, which is a pointer to, I assume, wherever it is that we're going to put it. What does get line take? It takes a size and a pointer, is that right? Let's have a quick look at get line and see. What does it do? Gets lines from afar. No, we don't want that. Get line buffer size and the pointer to the input buffer, which is standard in. So in that case, when we call get line, there's the buffer. Apparently, oh, here we go. Yeah, that's the pointer to the buffer. Buffer is the address of the first character position where the input's going to be written. Address is the size of the variable that holds the size, and standard is the input handle. Okay, that makes more sense. So this is where we're writing to. This is a pointer to how big the buffer is, and this is a reference to standard in. So let's go. Let's give it exactly hex 16. Now it's expecting what? Hex 10? So let's see what it actually read in at this point. Oh, we can see it there. It did read it all in. So does getLine like allocate a buffer or something? I can't remember. No, getLine, brace self, even so it's got input function. GetLine, address the first character position where the input character will be stored. It's not the base address of the buffer, but the first character in the buffer. This pointer type cause, oh yeah, that's fine. So that's a little bit confusing, isn't it? Because that's pointing to a completely different spot, which it looks to be on the heap. 4B160, yeah, it's on the heap. So it must actually allocate that on the heap and just return that. So that returns a pointer to wherever it's stored. Does it return the size? I can't see the size anyway. So previously that pointer that had the expected size in it. Sorry, where is it now? Here, CA4. Maybe that's just referring to the buffer size, but without telling you how many characters are in it. Okay, so where are we at now? We're still in read input and leave. So clearly read input returns that pointer on the heap, which we then call string length on. And that will give us, I'm assuming 17. Yep, 17 characters because of the new line at the end. And let's see what this is doing again. So I'm going to step through this just a little bit. Malloc. So we've got 2 pointers. We've got this one here. Let's go 17 bytes. That's the new allocation, and then wherever it was that we had before. Sorry, I should do the same thing. To wherever the other thing was. Hey, Zorkat, thanks for coming in, bro. I stepped so fast, I didn't realize how quickly we end up with all this text. Okay, so that's what we entered, and that's basically the matched malloc buffer that I assume we're going to be writing things to. Okay, let's quickly step through that again. Alrighty, now, first thing we do is we read out the size, and we set all of that stuff to 0. So you can see that's still our buffer, and that's, sorry, I just repeated the same thing, and that's still 0. So that's fine, which is a little interesting, but malloc has returned already null memory, and they're just making sure that memset, that the memory has been set to 0. And then we've got a couple of local variables that we set to 0 by the looks. Okay, and then we compare this to see whether or not, oh no we don't, we just jump straight away. Right. This, by the looks of it, this EBP minus 18 refers to a local variable that stores the current index, and this minus 10 is probably the counter of how many characters we should be going up. Yeah, no worries, Aaron. All good, buddy. Okay, so clearly what it's doing is saying have we reached the end of the counter, which we haven't. So we will move the index of into the string and add that to this secret buffer. That's what this is, right? So secret buffer is 1, 2, 3, 4, 5, 6, 7. There's probably, I don't know, maybe this is the XOR key that we actually need to be using like behind the scenes. It may actually do it all for us. So we read that first value out, which is here. And then into EDX we get the local variable, which is the index, and then we've got EAX, which points directly to our input buffer, and then we add those two together so that we effectively get a pointer to the first character, and then we read that character into EAX, which in our case is 0, and then we XOR that with the first value that was passed in. And the first value that was in first character, that's stored in the secret buffer. Just got a new follower. Thank you, whoever that is. Prosella Vadens. Thank you very much. And then once we've got that, we store that in EBP minus 1D, which again looks to be a local variable. Okay, and then do we get this secret buffer out again? Is that what this is? I can never remember. 858, 858, 858. No, it's different. So what's in EDX? Ah, okay, this is where you have now entered the duck web and you're in for a honking good time. So we XOR the first character, and then we take, again, our counter and get a pointer into this string and read that character out. And then we compare that with the value that we've just XORed. So here we go. This looks interesting. And if it's not equal, we do something else. Righto. So what it's saying here is that we've got a hex 19 bytes. Has everyone figured this out now? So this is the string that has, I would assume, hex 19 characters worth. And I would assume that we need to pass in a value that when XORed with the secret buffer. So let me just go through here. So when we XOR with this secret buffer here, that we end up with this string. Okay, so instead of that, let's go, what is hex 19? That's 23, is it? 16 and 9. It's 25. 25. So that's the secret buffer. And for each one of the characters in here, we need to be able to XOR it with a magic value to get the stuff that we're looking for. So let's jump into Python just quickly. I should probably vim this. So if this is the secret buffer, let's take that. Okay, so this is secret buffer. And let's hang on, what do we got here? It's a tab, isn't it? Substitute the tab with comma and a space. Okay, so there we've got our secret buffer there. And we've got this long string of text here. Copy. Text equals this long string of text. And then we've got the required size is hex 19, right? Which should be the same as this. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's right. So what we want to be able to do is basically just have a very simple XOR function. So actually, let me just do this. Hash bang. Oh no, we don't even need to do this. Let's write this to Pico. Which one was it again? It was reversing. Quack me. Let's call it solution.py. And hashbang user bin and Python. I'm just going to stick to Python 2, much to the dismay of a lot of people. Stream pico reversing quack me. Okay, so what we want to do is basically iterate through S1, S2, Actually, what I'll do is I'll call this the key and the string. So then we can say, the nice way of doing this is doing some kind of a map, right? But to keep this really simple, this is what I'm going to do. I'm going to go for C in, actually we'll call it for I in K, which is the key. We're going to yield return. Actually, no, we can't even do that. We need to go for I in range K because I need indexes. Yield return K of I XORed with S of I, but that's a character and an integer, so we'll have to go the order of that. Don't need to yield return, that's a different language. So that should give us a stream of bytes for the length of K. So if we went print list XOR secret buffer and text, that would just spit out a bunch of integers, I would assume. What happened? What did I do? Range len K. Let's just do that, even though I could have done required size as well. So if we do that and we char them instead, look at that. So instead of listing this, let's go, and there's our answer. Classic, huh? That wasn't so bad. Took me a little longer than it should have done, not gonna lie. But we got there in the end. Come on. Yay! Winning. Did that make sense?
I'm not afraid.
Hopefully that made sense. And we have another follow. Averna, thank you for the follow. That's very kind. Now we've got another general skills option coming. Should we go back to the... I hate crypto. There's only crypto ones up there. I think I'm just going to keep going. To be successful on your mission, you must be able to read data represented in different ways, such as hex or binary. Can you get a flag from this program to prove you're ready? Well, let's see, shall we? We can close this down now. And we'll go and see what this does. We're going to start from the very beginning. Make sure you understand how data is stored. Please give me blah as a word to make things interesting. Aha. Excuse me. Oh, a new subscriber. Who have we got? Kojima, thank you very much for the sub. That's very kind. Welcome to the stream. I don't think I'm familiar with your name before, so maybe you're a first timer as well. And if that's the case, muchas gracias, my friend. That's very nice. All right, have a look at this. I think if we go int, we can take these things here, right? As base 2, that should tell us. At which point, if we went int base 2 and we charred that, we get the T. Pass my OSE. Oh, did you really? Oh, that's so awesome, man. Congratulations on passing. That's fantastic. Love your work. It's a fun challenge, isn't it? All right, so what I need to be able to do is I'm just going to create a quick lambda function. We're going to call it B for binary. Is a lambda that takes a string, right? And what it's going to do is it's going to take the string that we've given it and it's going to split it on spaces. What it's going to do, we're going to map another lambda over it. So the value that we get out, we're going to map whatever that value is. We're going to apply CHR of int to whatever that value is to base 2. So that should give us basically it as a series of characters. And then we can just join that together. So if we go .join, Invalid syntax. Lambda. Lambda. All right, so for example, if we did B, and I just gave it all of that, and hopefully it spits out a word. So let's see if it gives us a different word. Yeah, it does. So, lamppost. Please give me blah as a word. Okay, so we can just go dot decode hex. I can probably do decode bin as well, right? Blah. Oh. Crap. That was stupid. Typos for the win, eh? Test. Dot decode hex. Computer. 164. Yeah. So what we'll probably need is another function, which is a lambda. Takes the string, and it's going to do the same thing, but this time it's going to map a lambda of value to char int of the value, just whatever it is that we give it. And that's pretty much it. We don't need to do any other magical things with it. Split on space. So if we go oh, can't type. That's what happens when I'm under pressure. Ooh. As a word. Am I missing something here? Is that ASCII? What do you guys think? First time typing? Yeah, thanks Parody for your cheap shots. Jerk. Yeah, so clearly I'm not doing the right thing here because that is not a word. So what is it? Do you reckon it's octal? Let's go back up to this function. Let's see if that's octal. If that's base 8. There you go, it is octal. Sneaky! Alright, so binary of that bottle. Decode hex. Fly. I almost did it again. Octal of this cake. Yay! Winning. Well, that's not so bad. That was quite fun. I think that's a good little exercise for people who haven't figured out encodings and whatnot before. I've got another general skills. Reading transmission, you can't see me transmission, and maybe something lies in problems. Blah, you can't see me. I think I know what this is. Okay, let's go back over here. And we'll go back to PicoCTF challenge. Cheeky. So no such file or directory. Cat.star. Permission denied. There we go. There it is there. That's cute. Website running. Oh, we got another web exploitation one. Let's have a look at that then. We can get rid of these that are no longer helping us. Push me. I am your only hope. You did it. Just a minute. Let's get back. see if there is any. See if there's anything special in here. No, there really isn't. There any? There's a website running here. Try to see if you can push their buttons. Now, are we still burping all of this stuff? Yeah, we are. Okay, so the request was just a straight post. Let's have a look at the source of that. You did it. How many of these? Form disabled. This incident has been logged and reported to DevNull. Really? Okay, so what's going on here? Form disabled. This incident has been logged and reported. So, boo.html. So what happens then if we go to button2.php instead of posting to it? Does it do the same thing? I assume it does. So we post to button 1, we end up with a response that says just basically click button 2. You did it, try the next button, which goes get button 2. And then it says go to boo. Okay. So all we need to do is post to it. So let's repeat this one. And we'll just go button 2. Well done. There you go. That was pretty easy, wasn't it? So gets were clearly disabled. That wasn't so bad. Elite web hacks. Man, if this is going to be another one of those horrible challenges where I need to do some stego, I'm going to be upset. There are quite a few forensics challenges here. Hey, we salvaged a Ruin EXT Supermagic 2 class mech recently and pulled the file system out of the black box. It looks a bit corrupted, but maybe there's something interesting in it. You can find it in here. IMG. Oh well, I guess we're going to do some simple reversing of stuff. What was this called? EXT Supermagic. Make directory EXT Supermagic. And let's get that with no check certificate. Yeah, bin walk for the win. File system carving. Let's have a look at what it says. It just says that it's data. Okay, what a surprise. It's hardly surprising at all. We now have a new follower. Another follower, Drunk Mowgli. Thanks for the follow. Nice to have you on board. Let's exit out of that. Okay, so let's just see what binwalk says. Ooh. Oops. There's a lot of what appears to be JPEG headers in here. That doesn't seem right. And each one of them is the same size. Does that seem legit to you? Oh, we had this problem last time, didn't we? What was the magic switch that we used? Rundal EX. How you going, mates? We're currently just working through some PicoCTF challenges from last year, 2018, and we're currently starting to tackle this EXT Supermagic challenge. So according to this, there is this EXT Supermagic 2 class mech image. So this is apparently a file system. But yeah, it says that it's corrupted, and according to binwalk, there's just a bunch of JPEGs in it. Thanks for the follow, Defends. Great to have you on stream. Yeah. So what did we do? Oh, it was this, wasn't it? Bin walk dash D, and I had to go JPEG and JPEG. Did that do it? No. Oh, it's the other way around. So we go dash DD. Was that it? With the right. I need an equal sign in here too. Jeez, I'm terrible. It's going very slowly this time. I don't think these are going to be valid pictures. Yeah, they certainly look corrupt, don't they? Are they actually, like... Oops. That is ugly. I don't think they're supposed to be pictures. What do you guys think? So what does an image file usually look like? Bitwise, thank you for the sub, mate. It's very kind. You are a legend. They do all look different. I'm thinking maybe there's just some butchered bloody... Every couple of bits or bytes is ruined or something similar. Like this one's interesting. You reckon Zed's Stego? I don't think this is Stego. Do you really think it's Stego? I don't know about... Whoa! Bitwise, man, he's going bonkers with the gifts. Dude, that's so nice of you. Thank you very much for gifting the subs. Man, that's epic. Super kind of you, man. Thank you, Bitwise. I don't know what to say. There's so many people out there that keep gifting subs. What desktop environment am I using? Currently, so I have Fedora Linux 30, and the window manager is i3WM. i3 window manager. So that's basically what it is. All it is, with a few custom bits and pieces, but that's pretty much all it is. Okay, so who wants to help me level up my foo? Because clearly I have no idea. No idea what to do at this point. Let's just see what this looks like. So there's a bunch of nulls near the start, which is probably why it thinks it's corrupted. I don't know whether I'm expecting to see anything that stands out to me here. Maybe like the whole thing has just been sort of XOR'd with FF or something. What do you reckon? Do you reckon if we just, like, there seems to be a lot of FFs, a lot of zeros. I wonder if we're just supposed to like completely munge the whole thing. You know what I mean? When in doubt, XOR. That's pretty much my theory. Butterflucker, that's pretty funny. Any metadata in the files? That's a good question. Sudo dnf install exif2. Is that what it is called? Hopefully there's... you guys love watching me install stuff. Ugh. Where's exif2? Exif2. That's what I want. Is there a package for it? Installing exif2. I'm probably just gonna have to download blah. Give me a nice installation so I don't have to think. I don't think there's going to be any metadata in these, to be perfectly honest. I think I'm gonna be cheeky. Download the image XIF distribution from here. I just know that I'm gonna do that on stream and it'll be painful. God, man, the gifts just keep on coming, don't they? Okay, so to be honest, I don't know whether there's going to be any worth in doing that. I don't think there's going to be anything worth playing around in this either, to be honest. But let's go. So there's stuff in there that looks like legit, right? If this is supposed to be an image of some kind, what is this filler.jpg? Look at that. That's interesting. If you have Image Magic can do it too, really? So what if I open this? If you've already got that installed, Magic. Go on, you want to give me a command line, Dean, that I can map this across all the files in the file system? Is there a really nice and fast way of doing that? Command line extract exif. How to achieve from the command line in Ubuntu. I bet you it's going to say UZX install. Ah, okay, so here we go. We can install image magic, which I'm pretty sure I have in here already. Lib image exif tool Perl. Yep, cool. Whoop. That was a fail. I don't even remember how I got that on the keyboard, on the clipboard, sorry. Image magic. Maybe you meant, let's see. Maybe I did. Maybe you could just do that for me. Also looks like there are snippets of text in some pics. Might be shitty. Scroll through each and construct the flag from partials. Yeah, I'm thinking so. That's why I hate forensics challenges. Like, go and find the pieces of the puzzle and then go and glue them together again. Okay, so what did the instructions say? Identify. So I've got to use image magic. Can retrieve data on an image with the following example. So that just says identify. But I don't see. Oh yeah, here we go. Let's just try one. Do I need to give it some flags? Verbose. Verbose. Ooh. PicoCTF. Exif. Corrupt. Although these, I'm kind of thinking that given that these file names that we saw before from the strings output, all of these fillers, pardon me, each one of these fillers, scroll up a little faster, see this? I'm kind of thinking that, you know, maybe not. Verbose star.jpg PicoCTF. What was it? Exit. Not seeing anything particularly pleasant come out of this, to be fair. With file names like filler.jpg, I think that that's exactly what it is. It's just noise. What happens when I do this? Oh yeah, so it is doing them all. No, stop. Okay, so there must be a lot of files that it's parsing here. Hello, Yusisuvacho? I think that's how you say it. Hello, thanks for joining on stream. Oops, I meant to pipe that to grep. Just to see if there is anything that comes out. Although, according to this, exif would be capital E, or maybe not. Let's just be sure. What are we doing? We are trying to solve a forensics challenge from PicoCTF 2018 at the moment. And forensics is a particularly bad weak point of mine. So I don't really know what I'm doing here. There are a bunch of JPEGs that have just fallen out of an image file that we've just got. So the challenge here is this one. Salvage some mech and pull to file system. The thing is, like, this file system thing, it says it looks a bit corrupted, but maybe there's something interesting in there. You'll find it here. So we've pulled that down and we're having a quick squiz through it now. But any good material for C#? On this particular stream, no, but if you have a look through my archive videos, which you can find, hang on a minute, just here. If you have a look through there, there's a bunch of C# dev stuff related to another project that I'm working on that I am live streaming, but just not live streaming today. Hopefully that's helpful. Okay, so what do we got here? Yeah, so corrupt, bunch of corrupt stuff, but nothing really interesting has fallen out of it. So yeah, I don't know. I don't think that's what we really are looking for. The thing is, like, I kind of want to go through and yeah, no dramas. I want to go through and look at this file system image just a little bit more, because, like, Bimwalk says there's a bunch of JPEGs in here, but there's got to be something more than that, right? So if we did this pipe grep, so there's not going to be anything in there. If we change the encoding to long, we don't see anything different, really, do we? Yeah, it's all ASCII. It's been interesting that we didn't see anything at all that resembles interesting text. Yeah. I'm out of ideas. I'm terrible at this stuff. What do you guys think we should do? Any ideas? I'm open to suggestions right now. I have to learn when to use a particular modifier. What sort of modifier are you talking about? Any ideas? Oh, okay. Private versus public. Well, the simple solution to that is default to private unless it needs to be exposed. That's pretty much it, right? Yeah. I don't know. Anyway, right, so this, see this, it says here, this is an image and it's called ext supermagic. So is this supposed to be a file system of a certain type? Poetic Dreamist, let's do that again, just to be clear. Ext supermagic, and we'll just pipe that to less. So According to this, there's nothing but images in it. Nothing but images. I'm thinking like for like ext3. Like if it's an ext image, then surely there needs to be like a header that implies that it's ext, which is why binwalk's not even finding it, right? So let's have a look, like size limits, journaling levels, functionality, undelete, compression, ext4 references. So what I want to know is like what does the ext image look like? Do you know what I mean? Does that make sense? How do I find the offset? What's this? Okay, what's this? Read blocks from any file system forensics, file systems and data recovery. Standard extension headers. Let's have a look. A magic number is a sequence of bytes that is used in all files of a certain format, especially in position. So this doesn't look related, does it? Magic number. Yeah, so I really want to see like an ext. Is there an example here? Like what does an ext file system look like? Oh, that's not going to help me. Ext structure. File system header, inodes and node table. Okay, so users, inodes. Do you see where I'm going? Like what I'm trying to do is get the file system stuff out of it. Extension header. This looks like it's unrelated. Okay, so let's go ext file system header example. Second extended file system. ext4. It's got to be an example somewhere, right? Without me having to dd. Autopsy. What's autopsy, mate? I don't think I'm familiar with autopsy. Okay, so out this book, chapter 2 definitions. It's a book. I don't want a book. I just want an example. Ah, it's a DFIR kit, is it? CBS sleuth kit. Autopsy. We have another follower. Gregorian 2002. Thank you very much for following. What do we got now? Okay, so we can just download. I assume we can just download and run this on Linux, yeah? Windows. Download the Linux sleuth kit. You will need a Java deb package. Follow the instructions. Ugh, deb. I'm using Fedora. To do so, download that. The next will need Java deb. Okay, that's okay. I'm thinking though, like, I might do this off stream, but right now, I'm thinking all we need to do is like, just adjust a header or two. So we just need to find out what it's supposed to look like. We can quite easily do it ourselves, right? So what do we got here? Superblock. What does a superblock look like? What does the inode table look like? Do you know what I mean? ext3, ext4. The inode described previously has a bunch of stuff. Total files. So if anyone can help me find something, can you show the output of debug fs? Yes, let's do that. Debug FS. Oops. Debug FS. Bad magic number in Superblock while trying to open blah. Really? Okay, so is that not exactly what we're looking for there? Maybe that's saying we just need to fix the magic number. I mean, it is called super magic, so we've got to fix the super magic value in ext. Yeah? Does that seem reasonable? Yeah. Cool. Okay. That seems legit then. Okay, let's try to do that. Can anyone help me find what the header needs to look like? I think your idea around headers images on the money. Yeah, I do too. I mean, the name of the challenge is a little bit of a giveaway. No. I don't know where to go from here. Where can we find out more information? Maybe we... Hang on, let me go back to that book that we had open just before. Let's see if there's ext to magic. Is this what we need to fix? 16-bit value identifying the file system as ext2. The value is currently fixed to ext super magic of value blah. Okay, so is this what we need to fix? Like, we just had another follower. We have indeed XMPH. Thank you very much for the follow. Oh, and Digital Sanctum as well. Thank you very much. I missed that one. Yeah, so I'm thinking that's what we need to do. We just need to figure out what the offset is. Yeah, 16-bit of magic value. 16-bit in the maximum number of items. State. Yeah. I was waiting for that. I'm so sorry, mate. I didn't see it. I just went through my list and I saw your name. I was like, oh, I didn't even mention you. But thank you for the follow, buddy. Sorry that I missed you before. My bad, dude. My bad. Okay, so if each one of these S's, maybe it's... hang on. It doesn't. Some of them are 32-bit, some of them are 16-bit. Okay, so what's the offset to the magic value in the super block? ext... offset to super magic value. Oops, can't type. Oh, I don't want to. No, I don't want to. I don't want cheats. Ext offset to magic header. Here we go. This might help. File signatures. Recovering from a broken petition table. Magic bytes. This is probably going to help. ext. Come on, give me some good stuff. Google Chrome, Extensional Archive. Yeah, is that it? We've already skipped them. I'm open to ideas. An example. Note that the exe family of file system is entailed by ordering, so the bytes appear in reverse order. So we're looking for 53EF instead of... We use DD to read the disk and XXD to dump. Ooh. Is that the hint there? How do we know? How do we know? Let's quickly go back to this for a minute. I would have assumed that it would be like one of the first values that you would see, but according to that example there, like that's quite a way in. Block size, skip 0, read 10. This looks like it's quite a way in, right? Fdisk. Am I missing something here, guys? EXT. How do I find this offset? There's got to be a super easy way of finding the offset, surely. Surely there is an easy way. So I'm getting messages behind the scenes. Okay, super block. Ah! Is that it there? The structure is mostly constant, blah. So S magic is at offset 56 and is 2 bytes in size. Okay. So, touch solution.py, gmod plus x solution.py, and let's gbim. Okay, so what we need to do then, if we just like read the whole file in, path, we can go with open path patch. Jeez, I'm getting excited now. Read bytes as f, return f.read. Okay, so if we go read in, what is it called? ext super magic.img. So we want to patch the bytes located at offset 56, right? So if we went contents equals contents up to 56, and then we add the magic bytes, underscores not dashes. You sure? File name has got dashes in. Yeah. No dramas, bro. And so what was the magic value we need? EF53. Oh, and this thing here over here said 53. Hang on. Yeah, EF53. Okay. Fixed to. Okay, so we basically need to pack it like a. It is slightly reversed, so it would be 53. Whoops, 53 EF plus contents from, I would assume, from 58 onwards. Def right path. With open path right bytes as f dot right. Okay, so then we can go right to solution.image. Contents. Bin walk. Oops. Image. I should just pipe that to less. Did that make a difference? Nope. Okay, so debug FS again. Yeah, that's a good call. Debug. Debug FS solution.image. Bad magic number. Did I have these the wrong way around? Bang debug. Okay, so maybe I've got the offset wrong. offset. They are the same size. What am I doing wrong? What do you reckon? Is it actually at offset 50, or do I have to like skip something else? So does the super block, like we've looked at the information here, disk organization. So super block. The super block is always located at byte offset. Let's do some constants. Super offset equals 1024. Magic offset inside that equals 56. Magic size, I should just call magic equals what would it be? X 50, is it 53 first? Probably is 53 first, so let's try to do some proper coding shit. Okay, so actually let's do this. So this would be super offset plus magic offset. Then we can add magic. And here we can go super offset plus magic offset plus len magic. Debug FS. Hey! We didn't get an error. How do I use this thing? Let's just bin walk this again. Aha! We have a file system now. Okay, so now we've got a file system. What do I do? Can I mount it? That's a good question. How do I mount it? Thank you. What's the command to mount an image? Linux mount image. I've done this thousands of times. How to mount an image file. Problem is that the image file is not there. Here we go. Is that what I need to do? Ooh. Thank you, sysop. That's helpful. Let's type that in. So let's just go and we'll call that mount. And then we'll go mount dash txt3. We sure it's ext3? Loop solution.image to mount. No, really? Sudo all the things. Ooh, wrong FS type. Really? Wrong FS type, bad option, bad super block, missing code page or helper. Yeah, let's try 2. Yay! Woo! Yay! We have a thing. Flag.jpg. Right down the end, I'm guessing. Ah, so now I gotta type this thing out, really? That's gross. Let's send this over here so that we can type it out straight away. Thanks for your help, guys. We got there in the end. Okay, so what do I need? PicoCTF. CD7. Oh man, it's mixed case as well. AB187 DF0BA6E E3, C3, C7. I hope they're uppercase C's. E. Where are we? A, 7, E, 3, B, 9, D, B, E, E. Okay, fingers crossed. Hey, winner. Winner, winner. Thank you, Bitwise. Awesome. Happy about that. Yeah, that was a bit meh. So, anyway, what should we do next? Should we do another forensics one, or should we try something a little bit different? There's a lot of forensics ones in here. General skills. In a file system, everything's relative. Can you find a way to get a flag? You can find it from blah. We could do this other general skills one. We can do a reversing one. There's another binary exploitation one. What do you want to do? This time you'll need to control some arguments. Should we skip to a binary one? What do you guys want to do? BOF2? BO2? Alright. Buffer overflows it is. You guys are so predictable. Copy link location. Excuse me. Copy a link location. We'll do the same thing with this so we can check. We'll have a look at the source as well. Alright, so we can I'm glad we figured that forensics one out. That was actually annoying me a bit. How do we unmount? Is there an unmount? How do we remove a mount? U-mount. Thank you. U-mount. Do I just give it the mount location? This isn't hacking, said who? I have read the terms of service. U-mount. Mount. Alright, thanks for your help. This is said who 12, just so that you know. This is a set of security challenges. This isn't actually illegally breaking into anything. We're not reversing anything that wasn't designed to be reversed. This is exactly the same as playing a game. The only difference is that the game that we're playing is reverse engineering and doing binary stuff. But it's completely legal and is not against the terms of service. Oops. Okay, let's see what this does. Alright. Righto, so main function, disable buffering, basically call vuln, which has a buffer size of 100 bytes, but just says give me as many as you want and then print them to screen. And then, oh, okay, I can see what's going on here. So then after that, so what we need to be able to do by the looks of it, you see how there's two arguments? Two arguments here that are passed in. We need to be able to overwrite. Yeah, well, feel free to go report me, mate. So what we need to do, you're not allowed to reverse engineer proprietary stuff, and we're not doing that. So it's really, trust me, it's not against the terms of service. Anyway, so we need to basically overwrite the return address of this vuln function with, I would assume, this win function, but at the same time we need to make sure that we specify these arguments correctly, otherwise it won't spit out the flag for us. Hey Bandit, we're just doing some PicoCTF challenges from 2018. We're about to do another binary. which doesn't look so bad. Now we are reading that in, so we can pipe it into the binary itself. Vol plus x vol. So if we do that, that's not going to do anything. But if we give it more than 100, it should crash. So if we gdb vol and we go disass win, we should get the address. So that's what we want to do. So effectively what we want to do is go python-c import struct, and we want to go print struct.pack integer, this value. We're going to do that, I don't know, 30 times should be enough, and pipe that into vol. Now what should happen is we get a printf saying file flag is missing. I'm hoping. There you go. File flag is missing, problem is misconfigured. So if we just touch flag.txt, we'll get something different. The problem that we've got is that this thing here, the values that we are giving it are incorrect. So instead of 30, I think if we go 25, 26. Actually, what I'm going to do is just rm flag so that I know when we don't get there. 27, okay. That's basically what we want, right? So 27, we want to do that 27 times will give us all the things. So 27 times 4. So we want 26 times 4, 25 times 4, 24 times that. So if we go a bunch of A's 24 times. Then we call struct.pack and we give it, which way around is it going to be? arg1 is higher on the stack, so we need to go dead beef first. Dead beef. Oops, I missed a plus. And then we add another plus. Struct.pack lox dead code plus struct.pack. Now there's a, if only the flag was controlled. Pipe that to vol. Ooh. Okay, so we got there, which is exactly what I was hoping for. Oops. Move flag into flag.text, right? So that didn't do it correctly. Now, instead of piping that into vol, I'm just going to put this in input, and then I'm going to gdb vol. Let's go break on win, and we want to go run and bring input in. Okay, so let's just have a quick look here. So let's just see how far off we got. Ooh, what a mess. So call's open, and here's where we're going to do some comparisons. That reads the flag. Okay, so what do we got here? Comparing EBP. So we want whatever that word is. That doesn't look right, does it? And what if we do C? Is that's the address of the function that we've just owned, isn't it? 485 CB. So we've gone too far. Where are we at? This is the flag. Wait up a second. Push, push, push. I'm just going to, let's quit out of that because we don't actually need it right now, but let's go into stream pico binary buffer 2. I'm going to quit out of this and just go back into that because I need this for, whoops, context. Got fat fingers going on my host. There's also a format string. Yeah, that's right, there is too. I don't think we need to do that though. So maybe what I should do to begin with is, I'm assuming that, you know, we've got this right. So let's GDB and run break on win and then run with input again. So what I want to do is just quickly look at, so we can see the stack here, right? So ESP is right near the top. And therein lies our problem. Okay, so how about we go... I'm still doing this. It's the other way around, isn't it? That's probably what my issue is. So instead of doing this, here's what I'm going to do. Just going to leave this as struct.pack. And I'm going to do that 27 times. And then we're going to do AAAA. B, 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 C, 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 C. All right, and let's run that again. Oof. Look at that. We actually got it wrong. So the current one is BPBB, that's what PC is. So we need to add another 2. Let's run that again. Okay, so we landed in win and we can see that our arguments fgetS. Right, so what are we comparing? EBP plus 8. So where is EBP? That's CCFC. So if we look at X, one lot of that plus 8, that's B. That's right, because AAAAA is basically the return address, right? Which can be nothing. So from here, we want to go dead beef. So struct.pack, oops, LOX dead beef, and then struct.pack LOX dead code. Oops. Rerun that. And then when we get down here, oh, that passed. And that passed. This is the flag. All right, so if we cat input and pipe that into Vuln, we get the flag. Yay! Winning! All right, so I guess we need to do this on the file server, on the thingamajiggy. Got another follower, have I? Meatball84. Cheers for the follow. So buffer overflow was in here. Copy. So let's go over here. And then what we'll do is we'll take this. And then we need to go and paste that and pipe that into vom. And there it is. PicoCTF. Nailed it. Another follow, Randall EX. Thank you very much for the follow, mate. See how easy that was? That wasn't so bad, hey. All right, it is midday. How about we do this little assembly, this reversing. This doesn't look so bad. I actually quite like these ones. We'll quickly bash this one out, and then we'll probably call it quits for the stream today, because I do have work to do. Oops. wget no check certificate, and then we'll duck back over here. This is reversing, wasn't it? Assembly 2. So what do we got here? Let's turn off highlights first, because that's a bit annoying. Now the question is, when you call asm2 with these two arguments, what does it return? Okay, so these are our arguments. Okay, so what do we got here? We got this and this. Now, EVP, the further down the stack we go, the lower the argument. So this one here will be OX21. And this will be, I think, X8, okay? So, it's pretty simple. We're taking that argument, putting it in EAX, and then that's a local variable, I would assume. And then we've got hex 8, which gets put into EAX, and then we overwrite another local variable. So that's 21. Sorry, that's 8, and that's 21. And then we go down, we skip part A, obviously. We're comparing hex with this 08. So that is the local variable, not the one that we've referenced to this. And if it's less than, which it is, we go back to part A. And then we add 1 to this counter, which contains 21. And then add A9 to the argument that was passed in, which is this. And then we come back out and we check to see if that is less than this. And then we return however many times we did that. Okay, so that in my view would mean this. Thank you for the follow, DT0V. Very kind of you. So we start with 8, right? See how we're adding A9 this many times until we get to that. Okay, so if we go OX3923, if I could type, that'd be good. Hello, off by 1. Good morning from Germany. Good afternoon from Australia. So if we subtract 08, we get that. Now we need to divide that by, what are we adding? A9. How many A9s can we fit into that? 86 of them. So if we go hang on a sec, 86 times OXA9, we end up with that, at which point we go this minus this just to get the difference, which is 85. But according to this, I just wanted to make sure that that's legit. According to this, if we've done this loop, minus 4 starts at 21, hex 21, and we add 86 to it. So 86 plus hex 21, we ended up with that, which in hex is OX77. So correct me if I'm wrong, like we're keeping a counter of it here, starting at, yeah, starting at 21. So my guess is that this is the answer. Who's with me? No! Maybe I got it the wrong way around. If that's not 21, then we start at 8. Three, 9, 2, 3. Minus hex. Maybe I have my arguments around the wrong way. Still 86. At which point we add. Oh, look at this. That's edge case. At which point we would add 86 to 8. Maybe it's 5e. What do you reckon? Nope. There we go. I was off by 1. My bad. Oh, it's less than. Yeah, okay. So we loop again if we don't. Okay. So I should have, even though there's 85 here, because of our comparison here that says less than or equal to, loop again, it's still less than. So yeah, we've got to go over. So there was an extra one. So instead of 77, it was 78. My bad. Sorry about that. I hope that made sense. Did that make sense? Anyway, we have skipped a couple. Next time we do this, I probably should go back to the crypto challenges, which I absolutely detest. But hopefully Peleus will be on and he can help me because I know he loves crypto. Loves it. It's just magic. So anyway, it is 10 past 12. So I've gone a little 10 minutes longer than I had intended. So thank you. But thanks for joining in. Had a pretty decent turnout despite the time of day. And I hope you enjoyed. We bashed through a few challenges, I think, in that one. Wasn't so bad. And we did a couple of forensics. We did a binary. We did a couple of reversing. I learned some stuff. I hope you guys learned some stuff too. And for those people who are watching who aren't familiar, like nothing we're doing here goes against the terms of service of Twitch. So, you know, let's not start looking for issues where there aren't any. But yeah, thanks again for everyone being on stream. Always appreciate your company and help and banter. It's always good. But in the meantime, as always, be good to each other.